In this tutorial, we're going to talk about the object data type, and it looks something like this. You may have encountered the object data type when writing to the console, for example. When we write to the console, there's lots of different method overloads we can use here, but you can see one of the parameters here is object, for example. So what is that? How does it work? Well, let's take a look at what the object data type is. If you watched my tutorials on inheritance, and also value types and reference types, then understanding the object data type will be quite easy for you. Now, the object type is the ultimate base class for all data types. So all types, user defined, whether we create instances of objects, reference types like arrays and things like that, and also simple value types like integers, booleans, characters, and things like that. So it's the ultimate base class for all of these types. It's a reference type, which means it's stored in the heap area of memory. And also it's kind of like an older technology now. Something came along called generics, and generally generics is a better practice, although you do still encounter the object data type these days. And using the object data type can present some issues and problems, which we will also talk about. And this is the process of boxing and unboxing. So let's take a look at an example now. So when I just said that the object data type is the ultimate base type, what does that mean? So remember before when I talked about interfaces, and we can pass the interface around into methods. And then when we implement the interface, then we can pass our objects around. And if we have multiple classes extending the same interface, we can just pass those objects around freely. This is pretty much similar to how the object base class works. Don't worry if you didn't watch those tutorials on abstract classes and interfaces. I'm going to explain it right now. So here we're just calling a method and we're passing a string. It just says hello world. The parameter is a string, which is great because we're passing a string, and then we're outputting it to the window. So a very simple application. Now imagine this. I'm going to change this string to the object keyword, just like that. Now let's run the application again. So you can see we have exactly the same result. So why is this happening? Well, it's simply because a string like this one here satisfies the is a relationship, and it is an object. Just like an instance of a class, for example, a video game class, a dog class, an animal class. They're also classes, but they're also objects. So this object keyword here can represent pretty much any data type in the system. Booleans, strings, and even integers, for example, 3, 4, 5, 6. The output will be the same, and there's no problems with compiling the project. So here we have an integer here, 3, 4, 5, 6. And we talked about it before. Simple integers, strings, characters, booleans, they're all value types. They live on the stack, in the stack area of memory. However, objects, they're reference types. These are stored on the heap. So what happens here? There's an implicit conversion happening here. This integer that we're passing in is being converted into an object type, and this process is called boxing. If we then convert this object value back into an integer, then this is called unboxing. And if you don't believe me, I'll prove it to you. Now, if you work with an object type like value here, it offers a few methods that we can use. One of them being called getType. And what that will do, it will get the underlying type of this object value here. So right now we're passing an integer in here. So if I run the program, you can see it's outputting the underlying type of the object, which is an int32, so a 32-bit integer. Similarly, if I pass in a string, let's say hello, then we're going to get a string, for example. So you can see this is the underlying type of the object right here, and we can get that using the getType method here. So let's talk about boxing and unboxing right now. So let's first talk about boxing. So what is boxing? So we have an integer here called num, and we're initializing it to 1, 2, 3, 4. Now what we're doing is putting this integer into a box, hence the name boxing. We're basically saying, okay, I want to create a brand new object. Remember, this is the ultimate base class for all types. And I want to give this the value of num. So now obj should equal 1, 2, 3, 4. Now I want to change the value of this num here to 100. Do you think this value will change with it? So what I'm doing, I'm outputting two of the values right here. So if we run the application, the value of num is 100, which is true because we changed it. But you can see this is not reflected to our object value right here. So what is going on here? I thought object was a reference type, and when something's a reference type, we have a reference to that area of memory. Well, this is the penalty of boxing. What happens here when you box something? You're pretty much putting this integer inside an object box, but because object is a reference type, all objects are stored in the heap area of memory. Simple value types like integers are stored on the stack. So what happens here when we're creating a new object and we're setting it to num here? We're pretty much copying this whole entire object, allocating some extra memory on the heap area of memory, putting that value in there, and then also creating the pointer on the stack to point to it. So a lot of things are happening when you do this here. Now, this is implicit, which means it happens automatically behind the scenes. You don't have control over this. So boxing a very expensive operation. When we looked at our example before where we passed an integer into the method and we had a parameter of object, all of this happens behind the scenes. A whole area of memory on the heap is allocated just because we're passing an integer and it gets implicitly converted to an object type. So this is the penalty of boxing, and it's also something we should consider very strongly, especially when creating large-scale applications. Is there a better way of doing this? Maybe you should consider of overloading the method instead. Like when we have console.writeLine, we have all these different method headers here. We can take in a char array, a decimal, a double, a float. But once we have all these possible values, yes, then there is an option to take in an object, but it's not mandatory, So there are design things to consider when using objects here, like this way, when you box certain data types. We could box a string, we could box a character, but in principle, this process is called boxing. Now, the opposite of that, as you may have guessed, is unboxing. So what is unboxing? Well, unboxing is pretty much the opposite, and that's converting a reference type, like object, stored on the heap, remember the heap area of memory, back into a value type, so then stored in the stack. So this is the opposite of boxing, and that's unboxing. So it's doing the process in reverse. Let's take a look at an example of unboxing now. So now I'm going to unbox this object here. So remember, the process of unboxing is converting a reference type into a value type. So let's take a look at that now. So I want to convert it back into an integer. If I convert it to a different type, then there's going to be an error. We're going to have a type conversion issue. So I want an integer out of this whole operation. That's the point. I'm unboxing the object back into its original type. So I set up an integer called result. And now what I want to do is convert the object to the expected data type. So this is the expected type I want, and this is the conversion. I want to convert this object to an integer. And this is the process of unboxing. So object stored on the heap, I want to convert it to a simple data type. And now it's going to live on the stack right here, this result integer here. So now, if I output the result to the console window, let's have a look at the result. So you can see I have my original value here, 1, 2, 3, 4. Now perhaps you noticed one thing about this tutorial, and that is, hey, I'm introducing this object keyword here, this object data type. But you shouldn't really use it that much. Yes, I appreciate that's the general theme of this tutorial, but it's good to be aware of this. In the early days of C#, It was quite common to convert various data types this way. So we convert it to a reference type and back into a value type. And that allows us to pass different data types as the ultimate kind of base class object. So it was quite useful. But then things like generics and other things were introduced, which kind of pushed this whole object notation of boxing and boxing kind of out of practice and out of fashion. But it is something to be aware of, namely because perhaps you might be working with older systems, or you might be working with systems that tie in with yours. Like it's called interoperability, where your software links with another piece of software, and you will encounter this object data type. As you can see, it's still in use today. Console WriteLine takes an object as a parameter, and many other methods and classes also use it. But it's good to know the principle of the object data type and the expensive process of boxing and unboxing, which is implicitly converting data types, value types to reference types, and then back again to value types. So there's quite a big overhead with boxing and unboxing in C#.